Evaluate the difference quotient, this fraction for function fx equals square root of x. When we have f of something x is square root of x, this x is input, and square root of everything, okay, that's output. Output is just whole thing, square root of whatever that is output. So to evaluate this difference quotient, we need to find f of this minus f of 4, subtract and divide by h. So let me find these ingredients. I meant f of 4 plus h and f of 4. Okay, we know that when we have input x, output is square root of x, so f of 4 would be simply square root of 4, which is 2. Let me find here, f of input is square root of everything, okay, square root of everything, that's 4 input, which is 4 plus h. In fact, 4 plus h is a quantity, but we don't need parentheses around. That's all we need on the top, and we divide by h. Now the difference quotient is given in the question, f of 4 plus h minus f of 4 all over h is equal to, in fact this intermediate work is not needed. We could have started right here. That is h on the bottom. This one we found square root of 4 plus h minus f at 4 is just 2. And whenever there is square root, we want to rationalize. Generally we want to rationalize the denominator, but since there is a square root on the top and there is a negative sign, we don't like this negative sign, so we need to multiply by its conjugate, which is plus sign. So conjugation means it's the same thing, just change the sign of middle. So we need to multiply this by, we have to multiply by the same thing, so that this fraction is 1 and multiplying by 1 is same thing. So this one 4 plus h, now we change the sign in the middle, it's a quantity, and same thing on the bottom, 4 plus h plus 2, it's quantity. Now there is no issue on the bottom. We multiplied top and bottom by this because we had minus in the middle and we had square root. So just keep writing whatever we have on the bottom. So h times quantity, I don't have to multiply, h times quantity 4 plus h plus 2. Okay, we need parentheses because we got two terms. Plus means two terms. On the top we need to multiply. Okay, the whole purpose of multiplying by this conjugate is to get rid of square root. How does this work? Like when we have a minus b, its conjugation will be a plus b, and when we multiply this quantity times this one, this FOIL multiply means we multiply these two and multiply here. So a squared plus ab minus ba, ba is same as ab, minus b squared. As you can see, plus ab minus ab cancel. That gives a squared minus b squared. Okay, this should remind you of something. This is difference of two squares, and we used this formula when we were factoring. Okay, so when we multiply a minus b by a plus b, which is conjugate of this, all we have to worry about is just the first term is squared minus last term is squared. The middle two terms cancel. So we can do the same thing here and not write all of them. So square root of 4 plus h, that's like a minus b and a plus b. When we multiply, a squared, so this quantity is squared. So let me simplify more. So we get 4 plus h. You're saying like this one is like a, this is b, this is a, b, right? A minus b, a plus b. When we multiply, a squared, that means this one is squared, and square and square would cancel. So we have 4 plus h. So here is 4 plus h, a square minus b square, right? And minus b square means 2 square, which is 4. And now as you can see on the top, 4 plus h minus 4, 4 and 4 cancel. That leaves, okay, that leaves h over h times quantity 4 plus h plus 2. Okay, now this is h times everything, h on the top, we can cancel. When we cancel top and bottom, there is 1 on the top because we are dividing. So this is 1 over square root of 4 plus h plus 2. And there is a plus sign in the bottom. That means we are not going to divide by 0, and which is an improvement. So we found the difference quotient for this function and simplified as well. Final.